Have you ever wondered how your phone knows the fastest route to a restaurant you've never been to? How does it know there's a traffic jam on the highway right now? And how can you virtually walk down a street on the other side of the planet from your couch? Google Maps isn't just a digital version of a paper map. It's one of the most sophisticated technological systems ever built by humankind. It uses satellites orbiting hundreds of miles above Earth. It uses specially equipped camera cars driving many roads around the world. It uses real-time GPS data from over 1 billion users. It uses powerful artificial intelligence, all working together in real time. Today, we're going to break all of it down, from how the map data is collected, to how your phone renders those beautiful tiles, to how traffic is tracked second by second. This is the complete story of how Google Maps works. Before Google Maps can show you anything, it needs to know what the world actually looks like. Building that picture requires data from 5 different sources, stitched together. Source 1. Satellites capture high-resolution images of Earth's surface. These images are updated regularly, with cities refreshed more often than remote regions. Source 2. Aircraft and drones capture oblique aerial photography to build 3D city views. Oblique images help create detailed 3D views when you tilt the map. Source 3. Street view cars and a fleet of other vehicles capture 360-degree imagery. Google has used cars, trikes, snowmobiles, and boats to photograph diverse environments. These vehicles have photographed over 16 million kilometers of roads. That distance is equivalent to circling the Earth more than 400 times. Source 4. Your devices passively share anonymous GPS data when Google Maps is open. When millions of people travel the same road, Google infers the road's existence and traffic direction. Google also learns how fast people are moving from aggregated data. Source 5. Local guides and businesses contribute photos, corrections, and new locations. Over 150 million volunteers help improve the map daily through MapMaker contributions. So, how does all this data appear instantly on your screen? The answer is map tiles. The map is divided into millions of tiny, square image pieces called tiles. Your device requests only the tiles covering your current view, not the whole world. Pan left and new tiles load, zoom in, and higher detail tiles replace lower ones. At zoom level 0, the entire Earth fits into one tile. At zoom level 20, you can see individual cars parked on a street. Each zoom level contains 4 times as many tiles as the one before it. At the highest zoom levels, there are over 1 trillion tiles covering the planet. Modern maps use vector tiles, which are mathematical descriptions of shapes, lines, and text. Your device's GPU draws these vector tiles in real time using WebGL. This is why the map rotates smoothly, labels stay upright, and 3D buildings pop up as you tilt. Tiles are served from Google's global network of edge servers, so the nearest server responds in milliseconds. This global network makes maps feel instant no matter where you are in the world. One of the most magical features of Google Maps is Street View, letting you look around on any street corner. Street View cars carry a specially designed rig with 15 individual lenses pointing in different directions. As the car drives, the camera fires continuously, capturing images every 5 meters along the road. In data centers, AI stitches overlapping photos into seamless spherical panoramas called photospheres. The AI fills gaps, corrects distortion, and keeps the horizon consistent across the panorama. The system also detects and blurs faces and license plates automatically to protect privacy. Street View uses Trekker backpacks to capture trails, museums, and beaches where vehicles cannot go. These Trekker systems have captured over 220 billion images across 98 countries. One underrated Street View feature is time travel, showing how places change over years. Google has been rephotographing streets for over 15 years, creating a visual timeline. When you navigate in Street View, you move between photospheres connected to each other. The arrows on the ground indicate which adjacent photosphere you will jump to when you click. Here's something that blows people's minds when they first understand it. Google Maps knows about traffic jams before many government systems do, and the reason is your phone. Every device running Google Maps or Android with location services enabled periodically sends an anonymous ping to Google's servers. This ping contains your GPS coordinates, your speed, and your direction of travel. Alone, that's just one data point. But multiply it by hundreds of millions of users, and suddenly, Google has a real-time picture of traffic flow on virtually every road on Earth. When a cluster of phones suddenly slows from 60 miles per hour to 5, Google's algorithms instantly flag that section of road as congested. The map turns red, and every other Maps user approaching that area gets an alert and possibly a rerouting suggestion before they even reach the jam. This data refreshes every 2 minutes. But Google doesn't stop at what's happening right now. Using years of historical traffic patterns, by time of day, day of week, and even season, a deep learning model predicts what traffic will look like up to 90 minutes in the future. That's how Maps can tell you, if you leave in 20 minutes, you'll save 12 minutes. Google also layers in data from road sensors, traffic cameras, incident reports from users, and, after acquiring Waze in 2013, community-reported hazards like accidents, police presence, and road closures. When you type in a destination and tap Get Directions, something remarkable happens in about half a second. Google Maps solves one of computer science's most famous challenges, the shortest path problem, across a graph representing over 50 million miles of road. The foundation is an algorithm invented in 1956 by Dutch mathematician Edgar Dijkstra. Dijkstra's algorithm works by spreading outward from your starting point, always exploring the nearest unvisited node first until it reaches your destination. The path it traces back is provably the most efficient route, but raw Dijkstra is too slow for something the size of the entire world's road network. Google uses advanced variants, A* search, which uses geographic heuristics to focus the search in the right direction, and contraction hierarchies, a technique that preprocesses the graph by creating highway shortcuts, dramatically reducing computation time. And here's the key part. Routing isn't just about distance. Each road segment is weighted by its speed limit, current traffic conditions, road type, and restrictions like no U-turns, one-way streets, and bridge height limits. The algorithm finds not the shortest distance, but the fastest time. Google also maintains separate routing graphs for each travel mode. Driving, cycling, walking, and public transit each have their own rules and constraints. Cycling routes avoid motorways. Walking routes prefer pedestrian paths. Transit routing accounts for live departure times. Once you start navigating, Maps reruns the routing algorithm up to 10 times per minute in the background. The moment a faster route opens up because traffic cleared on another road, you'll hear, "Faster route available," and the ETA, that's powered by a DeepMind AI model trained on billions of historical trips. Studies have shown it's accurate within a few minutes over 97% of the time. Most people use Google Maps to navigate from A to B and never discover the dozens of extraordinary features hidden inside the app. Let's change that. Offline maps. No signal? No problem. You can download an entire city or region to your phone in advance. The downloaded map supports full navigation, search, and turn-by-turn directions completely offline. Perfect for travel abroad or areas with poor coverage. Live View Augmented Reality Walking Navigation. Open your camera while navigating on foot, and Google overlays floating directional arrows directly onto the real street in front of you. It uses your camera feed combined with GPS and the buildings it recognizes to precisely orient you. No more turning in circles trying to figure out which way is north. Indoor maps. At over 10,000 airports, shopping malls, train stations, and stadiums worldwide, Google Maps has detailed floor-by-floor maps. It knows where the gate is, where the toilets are, and which lift to take. Some locations even support indoor turn-by-turn navigation. Eco-friendly routing. This feature calculates the route with the lowest fuel consumption, not just the fastest. It takes into account road gradients, traffic flow, and even your engine type. If If you've told Maps you drive an electric vehicle, it will route you past compatible charging stations, popular times, and life busyness. Maps shows a bar chart of typical busyness by hour, and for many locations it shows you live occupancy right now. Immersive view. Using AI to merge aerial imagery with Street View and 3D building data maps can generate a photorealistic 3D fly-through of a neighborhood. You can even jump forward in time to see a simulated preview of weather and crowd levels 3 hours from now. Google Maps has been reinventing itself with artificial intelligence, and the results are genuinely astonishing. Automatic map updates. Google's computer vision models continuously scan fresh satellite imagery, comparing it to existing map data and flag changes. When they detect a new road, a demolished building, or a changed shoreline, they flag it and often automatically update the map. This is how Maps stays current across 220 countries simultaneously. Flood forecasting. Google has trained deep learning models to predict river flooding up to 7 days in advance across more than 80 countries. When a flood is predicted in your area, a warning appears directly inside Google Maps, potentially saving lives in regions without sophisticated meteorological infrastructure. Neural radiance fields, or NearF. This cutting-edge AI technique synthesizes hundreds of photos into a fully photorealistic 3D model and powers immersive view. Now, a word on privacy. Google Maps collects a lot of data, and it's reasonable to ask what happens to it. The short answer is all location data is anonymized before it contributes to traffic or usage analysis. You can view and delete your full location history in the app at any time. And you can turn location sharing off entirely, though Maps will obviously lose some functionality if you do. Looking ahead, Google is integrating its Gemini large language model directly into Maps. This means instead of typing coffee shop, you'll be able to ask, "Find me a quiet independent coffee shop with outdoor seating open right now within a 10-minute walk." Natural language understood answered. The map of the future isn't a flat picture of roads. It's a living, breathing, AI-powered digital twin of the real world, updated in real time, navigated conversationally, and experienced in 3 dimensions. From satellites launched into orbit, to algorithms invented in the 1950s, to machine learning models trained on billions of trips, every time you tap navigate, a symphony of technology fires up invisibly to guide you safely to your destination. Google Maps is used by over 1 billion people every month. And yet most of us treat it like a simple tool, like a compass or a road sign. But now you know the truth. It's one of the most complex, ambitious, and continuously evolving technological systems ever created. If you found this video useful, or if there's a feature that completely surprised you, drop it in the comments below. I read every one. And if you want more deep dives like this into the technology hiding inside the apps we use every day, subscribe, because there's a lot more to come. I'll see you in the next one.